Hi, my name is Tom Hoeffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about the organic chemistry shortcut method. Now, in the previous video, which was an introduction to organic chemistry, we had no shortcut, and when we had to write out decane, we had to write it out like this, and it became very tedious to write down all 10 of these carbons, and really, I mean, look at all these lines, look at all these bonds, and then another 22 hydrogens. And by the end of that lesson, I'm thinking, man, I just wish there was a better way that we could show how to do decane structurally with all our rules, okay, but without having to take forever to kind of draw it out. The good thing is there is a better method, and it's called the shortcut method. And it has 3 tenets, okay? The first one says that there's a carbon on every end and bend, except if you see an atomic symbol present. Okay, so let's take a look at that first tenet and see how that would look for this compound that we have called decane. So it'd be as simple as this. According to this structure, this is decane. Now it says that there's a carbon on every end, so there's a carbon here and a carbon here, and at every bend, so here throughout the molecule. Okay, so let's count to make sure that we got 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So indeed, there's 10 carbons here. Okay, let's take a look at the second tenet. It's given that the remaining bonds will be with hydrogen. Okay, so one thing that I want to talk about with these lines here, some students at the very beginning of the shortcut method think that these lines represent carbons. They do not. They actually represent the bonds. So this line right here is this bond between carbon 1 and carbon 2. So carbon 1's right here and carbon 2's right here. This line is that covalent bond. So these lines are actually the covalent bonds that exist, in this case, between the carbons. Now, we know carbon has other bonds because carbon has to have a total of 4 covalent bonds. So if carbon 1 is showing only 1 bond, then it's assumed that the other 3, to get up to 4, are going to be with hydrogen, okay? And we see that in our drawing, okay? Now carbon 2 has 2 lines coming out of it, to carbon 1 and to carbon 3, to carbon 1 and to carbon 3. So these 2 lines are these 2 lines here. So it's assumed that carbon 2, since it has 2 lines coming out of it, that the other 2 bonds are going to be with hydrogen, okay? And that just kind of repeats it through until you get to the end where there's only 1 line, and that's when you have 3 other hydrogens, okay? So carbon at every end and bend, and then it's just assumed that the remaining bonds are going to be with hydrogen, okay? The last tenet is when we have halogens or oxygens in our organic structure, and this one does not. So let's go ahead and put a halogen. Let's go ahead and put it on carbon number 2. We're going to go ahead and put a chlorine group. Now remember, chlorine has a total of 7 valence electrons, and it can only make 1 covalent bond, okay? So we got a chlorine group here, and we know that it has 7 valence electrons, but in the shortcut method, when we come and put it in here, because we do these problems over and over and over again, we know that those lone pairs right here, here, and here, we know that they exist, okay? But in the shortcut method, we're trying to make things very simple and easy. So it's just assumed that those 3 lone pairs are there, okay? Obviously, with the oxygen, it's just going to be 2 lone pairs, okay? So those valence electrons are assumed to be there. We just don't see them visually in the shortcut method, okay? So let's go ahead and get into a problem, and let's see if you can understand what the problem is in the shortcut method instead of doing it with all of the valence electrons. So let's kind of erase this and get into a couple examples, okay? So let's say we had this structure here, okay? We're going to add some side chains to it. Let's add a couple fluorines, like maybe here and here, maybe an iodine here, and then let's go ahead and give it a double bond as well, okay? Now, if you don't know how to name this, you need to go back into the Introductory to Organic Chemistry. It's a previous video that I explain how to name it. And I'll review a little bit here, but I'm not going to go into great detail. So if you need the details, you got to go back a couple videos, okay, to Introduction to Organic Chemistry, watch that video, and then come back here, and then you'll probably be set, okay? So when we're naming these things, okay, we got a number from the side that has the closest double or triple bond. So the double or triple bond is actually closer to the right, so we're going to number this from the right-hand side to the left-hand side. If this double bond did not exist, we would actually number it from the left-hand side because the side chain over here is closer to the left-hand side than this side chain is to the right-hand side. But the double bond does exist, so we're numbering it from the right. So wherever I put a number, that means that's where a carbon exists, okay? 6 carbons long, so it gets the prefix hex. It does have a double bond, so it gets a suffix of -ene, and it's between a 2 and a 3, so we're going to call this 2-hexene, okay? And now we need to name the side chains, and there's fluoro groups and iodine groups, okay? Or fluoro and iodo in organic chemistry. And the rule is we got to put them in alphabetical order. So A, B, C, D, E, F comes before G, H, I, okay? So the fluoro groups are on the 3 and the 5, so we're going to call this 3,5 difluoro. And the iodo group is on the 4, so we call it 4-iodo. As far as the dashes, I'm not concerned about that at all. I just want to make sure we have our addresses, the locations of the fluoro groups on the 3 and the 5, and also the location for the iodo on the 4, as well as the location of the double bond on the 2. And remember, I'm putting my side chains in alphabetical order, and then, of course, the main chain is going to be the last word. So 3,5-difluoro, 4-iodo, 2-hexene. Let's try maybe 2 more. Let's try one that actually has some carbon side chains. Okay, so let's make this one a little bit longer. Maybe something like this. Okay, we're going to go ahead and add, let's add 3 chloro groups. Here, here, and here. And then we're going to add some carbon side chains as well. Let's go ahead and try to name this guy right here. So when we're looking at this, when we're numbering, okay, there are no double or triple bonds. Okay, so if there's no double or triple bonds, we just look for the closest side chain. This is on the 2 from the left. 1, 2, 3. This would be on the 3 from the right. So this one, we're going to number from the left-hand side. And this is 8 carbons long, so it gets the prefix oct. Everything is a single bond, so it's going to be called octane. And then we have 2 different types of groups here. We got the chloro groups, and we have this guy right here. Well, this carbon right here is part of the main chain. So the first carbon that's part of the side chain is right here. So it's 2 carbons long. And if it's 2 carbons long, it gets the prefix F. And because it's a side chain, we're going to give it the suffix YL. So this is actually an ethyl group. So when we're looking at chloro groups and ethyl groups, as far as alphabetical order, the chloro group is going to come first. It's on the 2, 3, and the 6. 2, 3, 6. And since there's 3 of them, it's going to be trichloro, followed by 4-ethyl. And I want to remind you, when we're naming these side chains, okay, we're going to put them in alphabetical order. So the C is going to come before the E. Remember, we're not using the prefix to alphabetize. We're only using the name of the side chain to put them in alphabetical order. So this problem is going to be 2,3,6 trichloro 4-ethyl octane. Let's try one last problem. I'm going to try to give it a couple different halogens and a couple different carbon chains. So I'm going to make this one even longer than the last one. So let's do the carbon chains first. I'm going to make this one have 3 carbon chains, okay? And I'm going to have 2 carbon chains that are only 1, okay? And then let's go ahead and add an iodine here, and we'll add maybe bromine here, and then we'll go ahead and add a double bond as well, okay? So since this problem does have a double bond, we are going to number it from the right-hand side. So we're going to have something that looks like this, 9 carbons long with a double bond. We're going to call this thing nonene. Okay, the double bond exists between the 2 and the 3, so we're going to call it 2-nonene. And I'll be honest with you, one of the biggest mistakes that I see from students is them forgetting to put the location of the double bond. They're so concerned about the side chains, they forget about the location of the double bond. Now, when I have a big problem like this, I tend to break it down into pieces. So I'm going to label this as an iodo. This is 1 carbon long, so it gets the prefix meth. And since it's a side chain, it's a methyl group. And this is a methyl group, okay? But this one is 1, 2, 3 long, so that is going to be called a propyl group. I have my double bond here, so it's ENE, and I've already taken care of that, so I kind of cross it out as I go. Now that I have everything broken down, it's really easy to alphabetize as I's and P's and M's. It's really easy to see that I have this in alphabetical order. Okay, so it's going to be 8 iodo, followed by the methyl groups, which come next, which is going to be the 5 and the 7, followed by the propyl group on the 6. So if you look at this, it's going to be I's, then M's, then P's as far as the alphabetical order is concerned. Remember, I am not using the prefix of di, tri, or tetra when we have multiples of the same side chain. Okay, so this is the answer: 8 iodo, 5, 7 dimethyl, 6 promo, and I forgot the bromo group here. Okay, we had the custodian come in and kind of caught me off guard. I tried to shoo him out a little bit. So we forgot about our bromo group here. So let's go ahead and put in 3 bromo. I got a little distracted there when he came in. So let's label this as bromo. And this is our problem here. So once again, everything is in alphabetical order, and we have our problem here. If you found this information to be helpful, please like and subscribe. And believe it or not, that extra comment that you put in the comment section helps this get to the top of the YouTube algorithm, and it makes it easier to share this type of information with other students that are learning that want to learn chemistry in a kind of like a straightforward fashion. Thanks.